Okay, so today we're going to be proving that a quadrilateral is a rectangle. I'm going to very quickly kind of refresh your memory on the parallelograms. So in order to prove a parallelogram, if we prove that both pairs of opposite sides are parallel, then we can say that it's a parallelogram. In a quadrilateral, if we prove that both pairs of sides are congruent, then we can say it's a parallelogram. So we went through all of these items, and we also noted how many formulas we'd have to use for each one of those. Well, if I use those same ones that I've learned so far, all I'm proving is that it's a parallelogram. So what makes a rectangle a rectangle? Well, we talked about that in the last video. What makes a rectangle is the fact that the diagonals are congruent, because they aren't necessarily congruent in a parallelogram. And another thing that makes a rectangle is we have 4 right angles. Okay, so I can use those two ideas in this problem. So example 1, I go ahead and hold on a second. So I have quadrilateral. Let's do G. So we have quadrilateral GHIJ. And G is at the ordered pair of 1, 1. H is at the ordered pair of 5, 3. I is the ordered pair of 4, 5. And J is the ordered pair of 0, 3. So we are trying to prove that this is in fact a rectangle. Okay, so in order to prove that the diagonals are congruent, that would mean I would have to prove that the length of GI is congruent to the length of JH. Okay, so I'd be using the distance formula twice. So GI, I would have 1 minus 4 squared plus 1 minus 5 squared gives me negative 3 squared plus negative 4 squared gives me 9 plus 16. So GI is the square root of 25, which is also equal to 5. Now I'd have to find the length of HJ. So HJ would have the length of 0 minus 5 squared plus, 3 minus 3 squared. Negative 5 squared is 25. 3 minus 3, I'm hoping I did not copy this down wrong. Oh, nope, I didn't. 3 minus 3 is 0. 0 squared is 0, so I get HJ to equal the square root of 25, which also equals 5. So I have the fact that both diagonals are congruent. So I can state that quadrilateral GHIJ is a rectangle because, again, this is the important piece, the diagonals are congruent. So how would I show that we have 4 right angles? What would I have to show? And I'm going to use the same diagram. So we're going to label this as example 2. I'm going to use the same points. So I have G at 1, 1, H at 5, 3, I at 4, 5, and J at 0, 3. So how else can I prove that this is or is not a rectangle? And that's by proving the 4 right angles. So if I am going to show that I have 4 right angles, let's see. that means I'm going to have to use the slope formula four times. Because how are we going to show right angles? We need to remember that if we are talking about right angles with slope, we're talking about slopes that are opposite reciprocals. So quick refresher on that. If we have a slope of 2/3 and we're looking for the opposite reciprocal, it's going to be -3/2. If we have a slope of 2 and we're looking for the opposite reciprocal, don't forget that this is the same thing as being written over 1. So that would be -1/2. So real quick refresher there. So I'm going to use the slope formula and find the slope of GJ. Remember, it's the change in y over the change in x. So I have 1 minus 3 over 1 minus 0. -2 over 1 gives me a slope of -2 over 1. I, much like my sides, want to use this one because these should be the same. That would show that they're parallel. Or I could, it doesn't really matter. Or I could do GH because I'm looking for opposite reciprocals. I'm going to go ahead and do GH, I think. GH. Change in y would be 1 minus 3 over 1 minus 5 gives me -2 over -4, gives me a +1/2. So notice these are opposite reciprocals, which means that those are perpendicular. So between GJ and GH, I can go up here and put my right angle indicator. Let's do that again for HI. Change in y means 3 minus 5 over 5 minus 4 gives me -2 over 1. Notice these are also opposite reciprocals, so those are also perpendicular. And I'm going to do IJ. And IJ is IJ. So I have 5. Now let's do 3 minus 5 over 0 minus 4. -2 over -4 gives me again 1/2. So those are opposite reciprocals. So again, those are perpendicular. Now we could go back and compare the slope of IJ, which is this half, and this one, and these are also perpendicular because they are opposite reciprocals. So I can state that yes, quadrilateral GHIJ is a rectangle because 4 right angles. Or you can say because all slopes are opposite reciprocals, something like that, but we have 4 right angles.